you, whoever that was. Um, uh, so many things to think about. Hitting that record button isn't always one of them that I got. So yeah, we are recording now, and because we're recording, and I had some stuff I didn't go through. Uh, oh, maybe a file. Let's save, and I'll lose that. What have we done in recording? I did go through the attendance, and I also had announced that we we're not having the exam this week. Well, mostly because I didn't announce it last week, and another reason is I like to take a little more time to prepare exams than other things that I do. Um, so it was easier for me to sort of slap together the um, lesson from the following week and move things around than it was to prep the exam with the time I had planned. It was a busier weekend than I'd really anticipated. Um, it's just that um, my home is a little different setup now this week. Okay, and let's see. I guess I can need to start my PowerPoint. Uh, um, um, where am I? Okay, and let me see participants. Do I have my chime set? Uh, play enter exit chime. Uh, all right. Um, I'm looking at Tony, and she's got some of her features shut down from what she had before. uh, sort of had a green top on before, but now it's black. Well, um, we are recording, and I think I didn't notice who made that comment, but getting that enough that we were just a few minutes in about what we talked about. So I can go to the PowerPoint slides again, um, share screen, and boy, there's a lot of stuff up, isn't there? Can share the PowerPoint. Um, and I guess I can go to minimizing this, sharing screen, and that's PowerPoint and slideshow from current slide. And what have we got? Yeah, there are certainly some strange things happened today. We're going to talk about this subject called correlation. It's a common language term, which you might see some places, but it has a formal definition in statistics. and we'll talk about that today. It's very commonly used. So we'll do the test next week. It'll be a take home. I'll make it available and try to talk about it and give some hints. I haven't even put a okay. We've got someone new showing up and Victoria Falls. Brad.
Yep.
Okay. All right. Brad's here. I can pop down and mark you here. Um, hopefully it'll let me. Okay. Looks like a slightly different color. I don't know. And that's the next slide. I did take attendance earlier. Let's see, someone else make it in.
It's Johnny.
It's Joni, and okay. We can make that smaller. Pop down and log Joni in. Up one. I just a lot to think about with attendance in the class. Where are we? Somebody else. Janice Joelle is here. Joni's Shaw. Oh, Megan is here, and get Megan's on the next slide. Pop down, Megan, and think we had another entry since Megan. Brad, Megan, somebody else, Brittany, Felicia. Okay, I think that's everybody on that chime. And just Shaw there. It's sort of a remnant slide. I guess I'll mention it. I have the last couple of times. It helps if you put the chapter number of the assignment and your first and last name on your assignment for me to help sort things out. I download them and mark them up with the software on my machine. So and I haven't returned anything yet, but I did have the exam all marked up and started looking at a few other things. So should be getting things back to you shortly, at least a few of them. And just well, it's still bright out, and I can see some snow outside my house. Although I do have the driveway pretty clean. I know some of you are probably on lockdown, and that makes things difficult. You can't do what you normally do. I'm it's been 8 days that I've haven't gone anywhere but my mailbox. So where are we? Correlation. Correlation. It's a common language term to say if things are correlated, meaning they're generally related. Um, but in statistics, it has some specific meanings. So and a formal technical definitions, and we can look those up uh, and display them. And eh, the actual calculation of correlation is pretty nasty. Uh, you can see it, but um, we have machines to do it. So um, we can those up. Oh, have a chat message. Oh, hmm, chat. Uh, well, um, I guess I had a chat message, and I'll have to say just a no right now. Uh, um, I can tell you what I've got graded, and I did submit the midterm grades already, although it doesn't have everything I've seen so far. Uh, what you know. Um, let's see. Calculating the relationship between two interval ratio variables. We got another participant. Is there a new name here? Uh, don't see a new name. I did take the attendance already, so you can interrupt if you just newly entered. Involves figuring out the sum of squares for uh, both variables, SS, like we have done. Uh, so now what you need to know is how to put means and sum of squares to show if two variables are moving in the same direction or in an opposite direction. Um, what is new? Correlation quantifies the strength and direction of uh, the two interval or two ratio variables. So we now can talk about how strong a relationship is between two variables. Um, allow us to see if the two variables are moving in the same direction. In other words, when one goes up, the other goes up, or the opposite, one goes down, another goes down. Those are that way. Up and down is relative to the sample mean of that particular variable. So um, let's the the book doesn't give instructors the art of most of the scatter diagrams. I, much of the time, we get scatter diagrams and they talk about correlation so we can see how they're related. And I did look at Wikipedia before to see how that works. And can I click that? No. Let me stop my share and go and escape. Yes, I want to keep them. And now I'm going to a Wikipedia page. Okay. And go to Zoom. And I can share just my screen. Right. So I'm sharing a screen, and this is Wikipedia, and um, so Wikipedia has an ad to participate in the world's largest photography competition to photograph a historic site and win a prize. So wherever you can get to a historical site. So correlation in statistics, correlation or dependence of any relationship between, and they give the definition here, though it commonly refers to the degree which a pair of variables are linear related. Familiar examples include correlation between heights of parents and their offspring, the price of a good, and the quantity customers are willing to replace it. Um, what have we got? Somebody new entering, Megan Brittany Joel. Oh, Samantha. Samantha can go back and get the PowerPoint and um, and um, get you marked in. Okay. Right. Where was I? I was on Wikipedia's page, and they have some definitions and background on correlation. But here we have some drawings with some scatter diagrams, and we can click on this. And what does this do? Enlarge. There we go, and we can even go show in full screen. So correlations are numbers between -1 and 1, and we have some scatter diagrams, so data on XY axis of various types of correlation when we calculate it. So this is a correlation 1, everything lining up on a straight line. This one about 0.8, we can draw a straight line, let's see. No, that enlarge doesn't really enlarge. We can go to full screen. So this is what a correlation of about 0.8. This is about 0.4. This is 0, no correlation at all. When we have a negative slope, we have a negative correlation. So this correlation of 0.4, this one about 0.8, this about uh, uh, negative 1. And now it actually doesn't matter how strong the tilt is, it's more like the tightness. So these are correlations of all of 1. This is 0 because it runs flat. And this is negative 1 and so forth. Now, some of the other the correlations are fit with, it doesn't mean there's no pattern at all. It doesn't, if it has a strong shape, we can construct various ways of getting 0 correlation. So all of these scatter diagrams are also 0 correlation. And we have some more slides. Here are some scatter diagrams with different calculated correlation coefficients. And you notice the stronger, the tighter the banding above the straight line, the higher the correlation coefficient. And if it's a positive slope, meaning it's increasing left to right, it's a positive number, and it's decreasing left. If it's decreasing left to right, it's a negative number. And what do we have to say? If we take just a segment of the drawing and truncate it, we'll get a much weaker correlation. So the blue lines there have a correlation of, I'm guessing about 0.51. But if we include the yellow and blue, we get almost 0.9. It's a rather famous set of scatter diagrams. And what do we have to say about this? Each of these actually has the same correlation coefficient. And I think it's about 0.7. So can I escape that? And go back and see, maybe I can get the comments on this one. So the ranges make a difference, and this graphic represents 4 data sets by Francis Ascom. You don't pronounce the E. I mistakenly said that one time. And in public, so for which some of the properties means correlation are the same, even though the data is different. So these have the same correlation coefficients, and reference there is in the American Statistician. And forget what it was. So all 4 of these graphs have the same data sets with the same correlation of 0.816. So what we would normally think of here, whoa, that blows up quite a bit, doesn't it? what we would usually think of a scatter diagram for correlation would be that way. And we can actually have like a bit of a polynomial curve, like the flight of a ball over space, projectile kind of motion. You might, if you truncate it appropriately, you can get a correlation coefficient. And we remember the correlation coefficient works for the whole straight. It works is based on the straight line. So there's another. Okay, do we have somebody new here? Joni Justice, Brittany, Brad, Megan. I guess Tiffany, Tamara, got you all marked. Here, Megan, Justice is here. I didn't have Justice yet. We can go and mark Justice here. All right, save that file, save, and go back to the screen here. Are you guys all seeing the scatter diagram here? Now?
Yep.
Okay. Sounds all right. Great. This is a scatter diagram. Again, the 0.816 value, and just 1 point off the straight line can cause a big change in the correlation coefficient. So that's one thing to consider. And the extreme values have a lot of influence on a correlation coefficient. So this has a correlation coefficient the same as the others. The sort of rule of thumb is you can believe a correlation coefficient, but you really need to plot the scatter diagram to see what's going on. Let me escape this. I can escape. Where am I? Maybe I need to go back. All right, go back worked. And more details. And all right, and go back that way. Well, yeah, that's all Wikipedia had on that graphic of scatter diagrams about correlation coefficient. Some other things about Wikipedia, certainly worth reading. And okay, same thing we've seen before. Examples of scatter plots. And a number of the formulas get nasty and so forth. So quite a bit to read there in Wikipedia. The comments. much of it's the same. I decided to use this because we'll um, the book doesn't have as many graphics as other books do with correlation coefficients, so I grabbed them up off of Wikipedia to get some background on correlation coefficient. So slideshow from current slide. Now, what have we done so far? Well, we've talked through this stuff, and you guys can see the PowerPoint here now, right?
Yeah.
Yes.
Okay, great. All right, I don't always know what I'm showing you. Right. We did look at those. Well, now, the Pearson product moment correlation, this is the formal name for the usual correlation coefficient. Long form Pearson's product moment correlation. Pearson had this often when we calculate the statistic, we call it R. And we computed using sums of squares, and we have X and Y values for a list of data, and it is this calculation, and it is fairly intense. This is as difficult as computing a standard deviation almost, right? Or a variance. We have to take the sum of squares, x minus x bar, square the sums, put both the x and the y. And then we have to get this SP, the product sum, which we multiply for each value which has an x and y point. So you can think of maybe height and weight. We subtract off the means of each and multiply them together, and we get this term here. Now you realize, of course, some of the values are going to be negative and some are going to be positive. When we have negatives at both sides, they'll cancel out and make a positive number. If we have negative on just one side, it won't cancel out, and we won't make a negative number. Okay. So SP is a new term. When x, y's are moving in the same direction, these are likely to be positive. When they're both above the mean together and both below it. Therefore, their cross products are like to be negative. This statement here, this is this other case, and what's missing here, Control P. or not moving. The word not should be there. It's important. One is likely to be above the mean and one is likely to be below. Therefore, the products are likely to be negative. So you can calculate the um, Pearson's product correlation from z-scores. So we can take our x and y values, compute our z-scores, and we have after we get our z-scores, we have a simpler formula for correlation coefficient. We just have to um, uh, compute the products of the x and z scores that are related on the same observations, and then compute the divide by n minus 1 gives us the correlation coefficient, which is not important. Idea here is correlation doesn't imply causation. In other words, one doesn't simply cause the other. Um, now there are things that are related. You start thinking of height and weight of a person. Yeah, taller people are generally heavier. You also might want to consider, but other times you don't know. In economics, for example, income and education might be positively correlated, and it doesn't imply one doesn't imply that one causes the other, although you would like to uh, the folks who get paid for teaching school would like to think that that is a causal factor. Um, and those of you who are in school now probably are hoping that that's true too. Um, and they have shared variance. So a couple of the things, this idea of reliability and validity are two common uses for correlation, and those are somewhat advanced statistical terms. Validity is that the statistical models we have match up with reality assumptions, and then reliability, the data is good on its own. And I think that's a leave chime, so I don't have to check it for attendance. Um, if a relationship doesn't form a straight line, Pearson's R wouldn't be appropriate. So here we have table 111, heights and weights, and some of the some of them might be unusual. The 60 inches is 5 feet tall, and 72 inches is 6 feet tall. And when we look at these numbers, that first one seems a bit unusual. Someone at 5'4", 170, and whereas the next one, uh, a bit thinner person at 5'7" and 140, and someone small in both senses. They're at number 7 at 4'11" and 97 pounds, um, and so forth. And then some people who are, heights that may not be a common adult's heights at 53 inches, which would be 4 feet 5 inches and 110 pounds. So we have those, have some, a few fairly short adults and in this page. And we would like to calculate a correlation coefficient. Well, we can go through and make a table and do all those hand calculations if we'd like. Or we could build that table in Excel, or we can use an Excel feature to do a correlation. So what have we got? I think, and they give another missed classes and final exam scores. Usually you'd think of a positive correlation between height and inches. We've got someone here returning. See if we get a new name. Brad, Justice, Joel, Tawny, Felicia, Victoria, Megan. Okay, I think I've got all those names. And we can go and look at second example. Generally, it's negative. The more classes you miss, you would think you'd get a lower exam score. And let's see if we can take the data and can escape from this. Yes, I want to keep everything. And then we can go to the Excel and data, height and weight from the original value, and how do we get a correlation coefficient from that? It's really kind of simple. This is it. Let's see. Just this command here, corral with 2 R's, and you highlight the first range and the second range that are next to each other, and you get it. So that's how you get the correlation there. And we can, I guess I took something off, close that. Really kind of simple. I need to redo this. Backspace and just that gets us that correlation coefficient. And getting plots in Excel is fairly easy. So home and where do we have that? Insert charts. Let's see, 2D line, or where is insert. Let me peg that line, spark line, This is scatter or bubble chart. So we'll use a scatter chart. Insert scatter chart. Um, um, it's not as easy as I thought, huh? We can delete that chart. Maybe if we highlight all these things and ask it to do a scatter chart, it'll give us something. So weight, height, and didn't put the height on the side, but its default chart. And I didn't select delete. Now insert and scatter and and we can play around with it. It does show weight as a function of height, and we do see scatter, and this is about 0.7 correlation, and it is believably linear from that plot. So we could check that. And Excel lets us insert charts fairly easily, and that's a positive correlation of that 0.78 or so from that data set. And we can make that go away, and there are ways to edit this and make it prettier and so forth. But that's one way to get a correlation coefficient in Excel. And we then, of course, could also look at Google Sheets. So go to Google page, and if you have a Google account, you can be set up and you can find slides, books. Keep Jamboard, Sheets. So there's Google Sheets. We can throw in a blank sheet, untitled, and it's working. And we can actually go to Excel and maybe copy the data table itself. Control C is a copy, Command, and go to Google Sheets, and maybe here, Control V is a paste, and it pastes the same way. So we have the data, and we then can see if we can get the correlation coefficient, and equals COREL. So we can just select that one, and then the first constant here, correlation, and then a comma, and then get the second term there. and close the parenthesis. And well, we get pretty much the same number with the correlation coefficient. So just as easy in Google Sheets. Can we? Will it let us insert a chart? Um, um, let's see, chart type scatter. Well, it ran the height and weight there, but it also included that other column. Let's um, what can we do? Can we right click this and delete it? What can we do with that? We can remove this one. X-axis. X-axis can be x-axis height, and let's see, and series weight. No, it's not giving me what I hoped for. Can we close the chart? Can we delete it? And maybe if I delete this row, delete the column, rather the column, select the results and insert chart. It gives me a scatter diagram, height versus weight, just as we some would hope for, and we can make it, a little more narrow if we want, or broader. We had it look a little more narrow before, so that's the height and weight chart in Sheets. Yeah, even easier. Once you fiddle with it, so we get correlation coefficients and so forth in either format. Go back to the PowerPoint. We also want to look at this Miss Class's data, and I believe I've entered it in Excel. Missed final, and that one, the data looks like that. I guess I left the chart in 0 through 6, and the correlation is -9.743. So I don't know if this is real data, but the instructor might have put this in to try to encourage people to attend class, right? The person who wrote the textbook is an instructor, and we have that data. we can take this data and we can copy it, Control C, and we can go back to Google Sheet, and it lets us insert, add a new sheet. So a new blank set, and just Control V. We have the same data, and again, can get the correlation coefficient, equals CO R correlation coefficient, and I don't know, can I select both columns? Will that do me? No, just need to select one, comma, and select the other column, close it, and it's a comma. So negative 97 again, so pretty high. And we can get a chart on that, insert chart, and missed versus final, and maybe not quite as nice a chart this time. The defaults are a little different, but still it's a reasonable chart, and it looks a lot like a straight line in Google Sheets. So if you happen to be someplace and you've only got a Chromebook, or you can still make charts like this and check correlations in both Google Sheets and so forth. So make reasonable scatter diagrams pretty quickly. Yeah, you could do this by hand, and again, there's some judgments about how low you'd want to go and to make your charts and what would make a nice chart. But and there's ways to customize both of them. So delete, publish, copy, chart, move, alt text. We can get those, and Excel has more things that let you fiddle with and make nicer charts currently than Google Sheets, but both are somewhat reasonable for many purposes. And go back to the PowerPoint. So we can look at that. We can do them both in Excel and Google Sheets, and work through the numbers that way. So we don't actually have to go through this calculation, calculate all the z-scores, and then the products of the z-scores, or this calculation, which is pretty time consuming if you were to do it by a hand calculation. And we can make those statements. Yes, this is a pretty strong correlation between height and weight of adults. And we've got some, I would think unusually short people there at somebody uh, at 4'5". It's an unusually short adult. Um, but on the tall side, I don't think we have 6'2.5". Not all that. Or 6'3" is tallest. Um, um, Here's step-by-step calculation if you'd want, and you can set this up in a spreadsheet somewhat easily. Although if you have a spreadsheet, we just showed there's just one simple command to do it. Uh, uh, okay, it's negative, so the negative sign means if missed classes increases, then the final exam score tends to decrease. And yeah, this is the setup calculation with table. It's easier with the Corel command in Excel and Sheets. So we can actually do formal tests of the Pearson's product moment calculation. Now, the statistic is R. It's an English letter, like we often do with statistics. We give them English letters. This letter here is a Greek letter rho. Okay, so this kind of swirly P is a rho, and it's what we use for correlation coefficient. Um, and we have two-tailed, right-tailed, and left-tailed tests. So we might only be interested if things are positively or negatively correlated. And we could test those, but often we're interested is if the correlation differs from zero. It's after 6, all right. So we have table 11 in the book, have degrees of freedom, and we can look things up. And I think, let me escape and see, do I have, um, um, do I have a table with a T table, R table? Okay, and view, zoom 200%. So I've got the R table that I've built so far. Um, and it looks a whole lot like the R table in the book, I hope. I tried to make it look that way. Go to the PowerPoint. So degrees of freedom, n-2 levels of significance, and we can identify a rejection zone. So if we want to do critical correlation coefficients. Depending on the value, we can use this table here. So use the rounding rules, stop at the third points is common, make the conclusion, calculating R, see if it's in the rejection zone or not. So there are hypothesis tests for it. And those have been developed. The coefficient of determination, R squared, is actually R squared, what we multiply the correlation coefficient from itself. And it's the percentage of variance overlapping between X and Y. Okay, so that's a way of thinking about this coefficient of determination. Oh, I should be showing the slideshow from the current slide. Yeah. Oh, we looked at those. And the hypothesis test based on the table and the R. So we have this idea of coefficient of determination, the percentage of overlapping of the variance between X and Y. So it gives us then a way of thinking about variances and X and Y with R squared here. It does show up a bit more in regression and analysis of variance. Further chapters. Pearson's rank correlation. So the relationship between two ordinal values, where the values are represented by rankings, we could just simply go through the same calculation if we had ranks or converted things to ordinal values with the ranks. And this is then the Spearman's rank correlation. And there's a different way of calculating it. When identical ranks happen on two consecutive ranks, the assigned rank for both values should be the average of the two ranks. So, and if there's no ties, RS is D, where D. So here's an alternative way of calculating that. Spearman's rank correlation it's often called Spearman's row. I guess I could write that. And it's pronounced row. Okay. And there's another way to do it. Another calculation format that gives us Spearman's row instead of taking the ranks, values of each of the difference in the ranks of X and Y and the numbered paired variables. So there is a shortcut formula for calculating Spearman's row. how helpful that is at this point, this shortcut formula. Um, now that you have Excel and you could get the ranks list, um, this is a simpler calculation than this. However, you have Excel or Google Sheets. Partial correlation is defined as a purified correlation between variables when one gets one controlling a third variable and holding it constant. So that's a partial correlation. The partial correlation we can do uh, by calculating the partial correlation of x, y when z is held constant by calculating the 3 correlation coefficient terms and putting them in this formula for partial correlation. Point by serial correlation is applicable in PBI when one variable has interval proportional properties, but the other occurs dichotomously 0, 1. So the result of a point by serial correlation is identical to the result of an independent sample t-test where equal variances are assumed, which is a chapter we skipped, the two-sided t-test with 2 variables. It's certainly worth covering, but I chose to follow Maggie Ross's schedule and skip that topic for this class. Not that wouldn't be worthwhile. Well, that's what I've got done for today. I guess about an hour short. We did attendance, but not a tech check. That's tech check, carry on column. We talked through Wikipedia on the subject. We used mostly to get graphs of the Pearson correlation coefficient. And Wikipedia, oh, and I did mention early on exam. Exam next week. And it'll be a take home again, and I'll give you about a week for it, and I'll see how I can put things together for various chapters. Should mention that. So Wikipedia has a pretty good discussion on it and some nicer graphs than we had here. Yeah, chat. The exam will be on chapters 5 through 8. So exam next week. Control P. Exam next week on chapters 5 through 8. Again, Wikipedia, we mostly use their graphs and talk those over. Pearson's correlation coefficient, the usual formula we look for. There's an alternative formula, has the Z's. We talked about correlation and causation. Correlation doesn't imply causation. Um, it could be random, or there could be an underlying causal term that affects both. Interpreting and describing Pearson's R. We've looked through example 11.2, and we showed showed Excel and Sheets calculation of R and scatter diagrams and plots of scatter diagrams. Okay, we did talk about a hypothesis test for R, and it's similar to the other hypothesis tests we use for T and Z values. I don't know why that is there. And we have coefficient of determination and Spearman's rank correlation. And so there are other extensions of the Pearson's R, which is the most common. Coefficient of determination shows, and it also shows up in regression, which will be topic for 2 weeks from now. And Spearman's rank correlation we'll have ready for you. And then a partial correlation coefficient. If we have 3 variables, we can a way to remove the effects of one of them, and it's a formula that involves all 3 correlations. And there's the biserial correlation, which is a odd topic. It's something I don't remember in my coursework or much of the stuff that I've read in statistics. Dr. Chachin Bowen is a psychologist and deals with some different kinds of statistics than I commonly would be dealing with as a engineering instructor, for example. We mentioned there that it's equivalent to doing a t-test to check the difference between 2 groups. There is a chapter on, there are in fact 2 chapters on t-test with 2 groups, which is a bit unusual. Usually those are in one chapter. But following Professor Maggie Ross's schedule, I chose not to cover that. Although seems like being it's not 7 yet, gonna let you guys go about hour early today. Probably should have had more stuff prepped through. So let's stop the share. Next week I'll have an exam ready for you. It'll be a take home. I'll give you a week like the last time, and I'll try to give you some advice on preparing for it next week, or working on it like I did before. I thank you all for coming here, and I'll try to get caught up a bit more on grading, getting things back to you. And I probably said that for 8 weeks or so. Yeah, it's possible. Life will run more simple sometimes. So well, thank you all for coming, and many of you've been very serious about the course so far. So your midterm grades, I think, should be available to you. I did submit them. So good evening. I'll
Thanks, Frank. Have a good week.
okay, you guys all have a good
Happy
week too.
Halloween.
Oh yeah, Halloween before the next class. Yeah.
Are we gonna go over a chapter next week too, or just the exam?
Well, I'll just go over the exam next week. That'll be it.
All right, thank you.
Okay.
Have a good week.
Okay. You too, Justice. Okay.